I'm going to talk through running a sensitivity analysis in the SCION model. So I have MATLAB open here. I have the SCION initialize and equations file open here. Now, for sensitivity analysis, you don't need to modify either of these files. So both of these files will be called directly from the sensitivity script. So what we do want to do is open a different file. So if I bring out here the SCION folder, we have the initialize and the equations, and then we also have down here some plotting scripts, and then we have the sense script. So if we open up this sensitivity script, it's relatively short, and there's not much in here. So what we do is we tell the model how many sensitivity runs to do. We then use a parallel for loop to run all of those models at the same time. We call run number n, the nth run that was done. We then make a common t-grid for all of these runs. Because it's a variable time step solver, the model will have a different time grid depending on what you're doing in the sensitivity analysis. So we interpolate each of the models onto the same time grid, which we just choose from the first run, and then we use that to generate some sensitivity distributions from the model, and then we use this sensitivity plotting. So it's a very simple script, but of course it's running many hundreds or thousands of model runs, so it can take a very long time. So make sure we have nothing saved in the console. Get rid of all this stuff from previous runs. And now we'll try running the script. Now 1,000 runs is quite a lot of runs, but the model does run relatively quickly, and I have quite a lot of cores, so it shouldn't take too long. So let's go for 1,000 runs. So this is running locally on a local machine. Now, the first time you do this, you'll have to start the parallel pool. So if you're running this on a local machine and you want to do a lot of runs, we typically use 1 to 10,000 runs for publication. You'll want to have a machine that probably has at least 10 to 20 cores, all cores that are relatively quick. So this machine has 40 cores, but they're not particularly fast, but it should do this okay. So you'll see the parallel pool is still starting. This may take a little while. Okay, so the pool is running. We're connected to 40 cores, so you want to check that you're connected to the amount of cores that you think you've got. And what we should now see is completed model runs coming into the screen. So we have about the first 40 there. And the second 40. So each model run takes on the order of several seconds. So for 1,000 runs, we should be waiting less than a minute. It is of course possible to do this on HPC. So if you look in the script here, you'll see there's a shell script, which I'll just quickly open in Notepad. This may be different depending on your HPC architecture, but we're setting a time limit, a memory limit. We're asking for 40 cores here. We're using MATLAB, and we're not going to display any graphics. And then we're just running this same SCION sensitivity script. So you can upload the whole SCION folder onto your HPC and submit this shell script into your queue, and from there that should then run your model, and it should give you the same output as we get here. Typically it sometimes takes more effort to do modifications and upload the file onto the HPC than it does to just run these locally. Most modern PCs can have quite a lot of cores and they're relatively quick. So the utility of doing this on HPC with this version of the model is not particularly high. Okay, so it's finished here on the local machine. We're running the sensitivity plotting script. And here is our output. So by default, the script gives us some sensitivity windows for these are actually our forcing. So there is a slight error here. It says delta 13C carb here on both of these, but actually this is the model forcings that it's used in the sensitivity range. This is 34S, 13C, strontium isotopes, O2, sulfate, atmospheric CO2, global average surface temperature, ice line, and nutrient concentrations. Now, as well as that script, it's generated a sensitivity structure. So there are a lot of things here that it's loaded in as the proxies to plot against. But you also here get run and sense. So run contains all of our 1,000 model runs as individual structures, each of those with the things that we recorded. Sense is a summary structure which contains all of those runs together. So if we look at sense MRO2, what we've got here is each model has its own column with the O2 values in here. So we could plot all of these if we're interested in things like outliers, for example. So if I make a figure, and if I now plot sense time in a million years, sense.mro2, what I'll get here is each individual model run and its O2. So this can be useful to see if any of your individual ensemble members are doing anything crazy, or exactly what is driving the differences in the uncertainty at different times. So that can be quite handy to plot. And that's pretty much it for sensitivity analysis. You can open up the sense plotting script, which will give some further information on what is happening. We're defining some colors. And in this sensitivity, we're plotting the full range. It's a max and min. So you could change this to be different confidence intervals or standard deviations if that was more appropriate. Or add other things, of course, to the script. So that's everything.